Next exercise 10, question number 1. A motorcycle of mass 200 kg is moving along level road. So this is weight is it is in a road 200 kg. So the weight is 200 g then, and from the road it gives a normal reaction R, and the motorcycle engine provides the force of thrust. This is going to be 1000 Newton, and the total resistance has a constant force magnitude 600. So 600 usually will mark here resistance 600 Newton. Calculate the acceleration. So F equal ma to this direction. F is 1000 and minus 600 equal m is 200, not g, 200, and a acceleration. So 4000 sorry 400 equal 200 a. So a equal 400 divided by 200, that is 2 ms minus 2. So if we want to find r, then f equal ma to upward, then r minus 200 g equal m times, there's no acceleration, it's not flying nor sinking, 0. So r minus 200 g equals r equal 200 g. Question number 2. A man of mass 86 kg is standing on the lift. This is the lift. Man is standing. So his weight is 86. So it's going to be 86 g from the center of mass, and so he gave a reaction to, man exerted the force on the lift, and with the Newton law he got the reaction S. Now we have two systems if we consider separately. One is man, so that is 86 g, and S is here, and the lift. So lift, you got the force S, and if there is a tension hanging, so there is a tension T. So this is the setup. This is moving upward with 2 ms minus 2. So we need to find this S. F equal ma. So we have to consider this one to the man upward, this system. S minus 86 equal m is 86 g equal 86 times e is 2. So S equal 86 g plus 86 2. S equal 86 when you take g is 9.8 plus 2, that is 86 times 11.8. So that is 1014.8 Newton. So that is the man exerted on the lift and as well as lift etc. on the man. So that is downwards. Question number 3. A car mass of 800 kg traveling along the straight horizontal road. So 800 kg, 800 grams, kilograms, so 800 g. And the normal force will take R, and then a constant retardant force of Fn reduces the speed. Assume it is moving to the side with A. So this is the F. And if we put F equal ma to this direction, then the force is also F. M we know that 800, and A acceleration we don't know. So if we know A, we can find F. Now they will tell that as a story. So it will assume that this is 18 ms minus 2, and at the starting, when it start, 18 m minus 2, and after some time it will bring into the 12 ms minus 1. So its speed reduced by 6 units in 2.4 seconds, or 2.4 seconds. So v equal u plus et to this direction. V is going to be 12, and so starting speed 8 plus A we don't know, that's the one we won't find, so this is going to be 2.4 times. Then A is 12 minus 18 divided by 2.4 minus 6 divided by 2.4. So that is minus 2.5. Now this is 1. Now from 1 we can write F equal 800 times. Now we know A is minus 2.5, that is minus 2000 Newton to this direction. It means for this direction it is 2000 Newton. Next one is we need to find the distance. So we can use SU plus V divided by 2 times T. So S equal 12 plus 18 divided by 2 times time is 2.4. So this is 12, 20, 30. 30 divided by 2, 15 times 2.4. This is going to be 36 meters. We have to write, we can't just write U equal 18, V equal 12, T equal 2. S. Yes, that's all. Question number 4. A block of mass with 0.8 kg is traveling along a straight, is pushed along a rough horizontal force. So this is a rough flow, then there is a friction. Let's see that friction is F, and this weight is 0.8 g, and the normal force is, normal reaction is R. By the constant horizontal force of magnitude 7m. So this is 7m. And the block increase 2 meter to, so starting from here. Okay, actually somewhere I will take that. So 2 ms minus 2. This is 4 ms minus 1. And that distance is 48 meter. During 8 meters from 2 to 4, the speed is increased. Now, when we put F equal ma, we don't know acceleration. So this data is given to find the acceleration. So we know that u equal 2, v equal 4, s equal 4.8. We need a. The best fit is v square equal u square plus 2as. S equal v square minus u square divided by 2a. So v square is 4. 4 square minus 2 square divided by 2 times a. A is 2s. So 2 times s is 4.8. So this is 16 minus 4 divided by 9.6. That is 12 divided by 9.6. This is going to be 1.25 ms minus 2. Now we need to find F frictional force. So F equal ma to this direction. Then there are two forces acting on. One is 7 and other one is frictional F, which we want to find. And m is 0.8, and we found out this is 1.25. So F is 7 minus 0.8 times 1.25. So that is 7 minus this value is 1. So that is going to be 6 Newton. And if we want to find R, F equal ma to upwards. So R minus 0.8 g equals 0.8 times 0. There is no acceleration up or downward. It means no flying, no sinking. So this is equal to 0. R minus 0.8 g. R equals 0.8 times 9.8. That is 7.84 Newton. Question number 5. A car is mass 1200 moving along a level road. 1200. The car engines provide a constant driving force. It's F1. And the motion of the car opposed to the resistance. So there is a resistance. So we'll consider this is F2. So this is 1200 G. And the normal reaction is R. And given that the car accelerating 2 ms minus 2, so the acceleration also given 2 ms minus 2. The magnitude of the driving force is 3 times the magnitude of the resistant force. So F1 equal 3 times F2. This is also given. We need to find the driving force. So we'll put F equal ma to this direction. So we can see the two forces, F1 minus F2 equal m is 1200 times a is given 2, and I know now F2, F1. So there are F1 minus F2 equal 2400. So this is equation 1 and this is equation 2. Two equations, two unknowns we can solve and find. So what my plan is, I'm going to find F2 first. F1 is 3F2. So from 2, F2 and 1. So F1 means 3F2. 3F2 minus F2 equal 2400. 2f2 equal 2400. f2 equal 1200. Then from 1 we need f1. So f1 equal 3f2. So 3 times f2 is 1200. 3600 Newton. Question number 6. Forces of 3i plus 2j and acting on the particle was 0.5. Find the acceleration. So f1 is, we'll take f1 as 3i plus 2j and f2 as 4i minus j. So this is acting on the particle with mass is given 0.25 kg. So F equal ma mean F mean there are two forces F1 and F2 in a vector form. So m is 0.25 times e. So F1 mean 3 and 2 and 4 and minus 1, 0.25a. This is going to be 3 plus 4, 2 minus 1, 0.25. This is 7 and 1, 0.25a. So a 0.25a equals 7i plus j. A equal 0.25 mean 1 over 4. It means this is a is 4 times 7i plus j. So we can multiply by a vector by a scale. So there is no problem. 4 times 7, 28i plus 4j ms minus 2. If they ask what is the magnitude, then we can find 20i square plus 4 square root, and the direction we can see this is 28i, and for this particle this is 4j. So we'll take this is theta, for this is 4j. Tan theta equal 4 divided by 28, which is 1 over 7. Theta equal tan inverse 1 over 7. Question number 7. If 1 is minus, I will take as minus 2 minus 2. If 2 is 3 minus 1, and if 3 is a minus 2b, and mass is given 2 kg, and acceleration also given 3 over 2. So 3 and 2. So we'll put F equal ma in the vector form. So this is F1 plus F2 plus F3 equal m is 2 times a is 3 and 2. So this is F1 minus 2 minus 1 plus 3 minus 1 plus a minus 2b equal, I will expand this one. So 2 times 6 and 4. Then this is going to be minus 2 plus 3 plus a minus 1 minus 1 minus 2b equals 6 and 4. So this is going to be 1 plus a. This is minus 2 minus 2b, 6 and 4. Then 1 plus a equals 6. I will write 1 plus 8 times I plus minus 2 minus 2b j equal 6i plus 4j. So when we compare I component, so 1 plus a equals 6, and when this is going to be minus 2 b equal 4. So from here a equal 5 minus 2b equal 6, b equal minus 3. I think that's a small mistake. This is not minus. So this is not minus. This is not minus. So then 2 plus 3 is become 5. Then 5 plus a is 6, a equal 1. And b equal minus 3 is fine. So a equal 1 and b equal minus 3. Question number 8, slide of mass 2 kg. So mass is 2 kg. Initial rest on the horizontal plane acted upon force of 2i plus 4j. So force is there, let's say F1, 2i plus 4j for 3 seconds. Find the magnitude of the acceleration. So F equal ma. So this is F1 equal 2 times a. So F1 is 2i plus 4j equal 2 times a equal half a times 2i plus 4j. So a equal I plus 2j. So mod a equal the acceleration size 1 square plus 2 square root, that is square root 5, and the direction, we don't need the direction. If you need the direction, this is the direction, so this is the particle, so I and 2j. So if it is theta, then theta equal 2 divided by 1 is 2, theta equal tan inverse 2. They don't ask in the question. And find the distance traveled in 3 seconds. So initially it is 0, and we have a now square root 5 ms minus 2, and t is given 3s. We need to find the distance. S equal ut plus half at square. So s is 0 times t is 3 plus half a times square root 5 times t is 3 square is equal 9 over 2 times square root 5 meter. Question number 9. F1 is given 3ai plus 4bj. F2 is given 5bi plus 2aj. And F3 is given 59 minus 18j, and m is 2 kg. So they are in equilibrium. It means F equal ma when we put F1 plus F2 plus F3 equal m is 2 times equilibrium. It's not moving. It means acceleration is 0. It means F1 plus F2 plus F3 equal 0. So 3a 4b plus 5b 2a plus minus 15 minus 18 equal 0, 0. So 3a plus 5b minus 15 and 4b plus 2a minus 18 equals 0, 0. When we consider I component, 3a plus 5b minus 15 equals 0. So 3a plus 5b equals 15, 1. Then j, 4b plus 2a minus 18 equals 0 when you consider j component. 4b plus 2a equals 18, that is 2. Now we want to solve those two simultaneously to get a and b. My plan is to get rid of a first and find b. So multiply by this one 2 and this one 3. So 1 multiplied by 2, this is going to be 6a plus 10b equal 30. And 2 multiplied by 3, so this is 12b plus 6a equal 3 times 18. That is going to be 54. This is 3 and 4. So we'll take 4 minus 3. Then this is cancel out. 12b minus 10b equal 54 minus 30. 2b equal 24. b equal 12. Now from 1, 3a equal 15 minus 5b. 3a equal 15 minus 5 times 12. So 15 minus 60. So 3a equal, this is going to be 50, 45 minus a equal minus 15. So we found out a and b now. A equal minus 15, b equal 12. Now part B, it says that this one is removed now. The magnitude and the direction of the resulting acceleration of a particle. Now it is unbalanced. Now what is F1? F1 is 3 times minus 15 I plus 4 times 12j. F2 is 5 times 12i plus 2 times minus 15j. So F1 equal, so we can calculate like this, and we can find F1 plus F2 the total, or the other way we know that F1 plus F2 plus F3 is equal to 0. Then F1 plus F2 equal minus F3. So we need to find F1 plus F2. So instead of working on this one, it is equal to minus F3. So minus F3 is given minus 59 minus 18j. So this is going to be 15i plus 18j. So F equal ma when we consider the total force is 15i plus 18j equal m times 2 times a. So a is half times 15i plus 18j, which is 7.5i plus 9j. So we need to find magnitude. So mod A is 7.5 square plus 9 square root, that is 137.25 square root 11.7 ms minus 2 approximately, and tan theta. So this is 7.5j and this to this 9j. So if this is theta, tan theta equal 9 over 7.5, theta equal tan inverse 9 over 7, tan inverse 9 over 7.5, which is 50.19 approximately from positive I. Now we need to find, the next question is the distance traveled by the particle in 3 seconds its motion. So this particle, now we have the acceleration is, we found out 11.7, a is 11.7 ms minus 2, and t is given 3 seconds, 3s, and starting acceleration is 0, velocity is 0, is equal ut plus half a t square, so is equal 0 times 3 plus half 11.7 times t square 3 square, so is equal half a times 11.7 times 9, so this is 105.3 over 2, so approximately that is 52.7 meters. Question number 10. The car is driving its trailer in a straight horizontal load by two particles, car and a trailer. So horizontal road. So the car weight is 1400 kg, 1400 mass, so that is G, and the resultant force is R1, and it is downwind. So there is a tension, and this is 700. So this is 700 G, and this is going to be R2. The resistant motion of the car is assumed to be constant at 630. So this is 630 Newton to this one, and then other 280 Newton to this one, and the engine driving force is 2380 Newton. So find the acceleration. So this is the tension, and as the standard sum, F equal ma to whole system. So when we consider whole system, the internal force we disregard. We have 3 external forces to this direction. It is moving to this direction. So that is 2380 minus 630 minus 280 equal m. So what is the total now? 700 plus 1400 both together, and acceleration is a. So this is going to be 1470, and this is 2100. So a equal 1470 divided by 2100, that is 0.7 m is minus 2. Now we want to consider the tension. We want to find the tension, so we'll consider this setup. F equal ma to trailer, two forces, the T and 280 equal m is 700, and now we know a is 0.7. So T equal 280 plus 700 times 0.7. So T equal 280 plus 490, T equal 770 Newton. If we need to find R1 and R2, so when we put F equal ma to both, we will get, assume for this one, R2 minus 700 G equal 700 times 0, so R2 equals 700 G. For the other particle, R1 minus 1400 G equal 1400 times 0, it is not moving, so R1 equal 1400 G. When the car is touring 12 ms minus 1, so the rope is broken and then we drop the trailer. So now the car is there, the driving force is there, and resistance force is 630 Newton there. And that is speed is 12 ms minus 1. So we need to calculate find the distance moved by the car for 4 seconds after. Right. So now we don't have the new acceleration. So we want to find again F equal ma to this direction. F is 2380, 630 equal. M is 1400 times new A. So this is okay. If you want, you can take E1. So E1 equal, this is 1750 divided by 1400. So this is going to be 1.25 ms minus 2. Now we have the acceleration as well, 1.25 ms minus 2, and after 3 seconds, so starting u equal 12 ms minus 1, A is 1.25 ms minus 2, and t is given 3 seconds, we need 4 seconds. So we can use S equal ut plus half at square. So S equal the distance we need. U is 12 times 4 plus half a times 1.25 times t mean 4 square. So when you solve this one, so you will get 58 meters. So now the part D, the tower of is inextensible, so we want to write the assumption of it. The tension is constant throughout the length as a result, and the acceleration of each car and trailer is same. So acceleration of car and trailer is same.